Welcome to Programming Rainbow. In this video, we continue on the beginner series to SDL3 in the C language. This is the 5th video, so if you want to following this video, you can go to github.com, Programming Rainbow, and this will be Beginner's Guide to SDL3 in C. You can git clone that repository, move inside the directory, and open it up with whatever editor you would like. So this is the 5th video. If you just clone this repository, what you'll find in the source directory will be the source for the final video. But since this is the 5th one, we are continuing on with where we left off with in the 4th video. So you'll want to delete this source directory and copy video 4 and rename it to SRC so you can follow along with where we are now. Let me just show you the project real quick. 08, and we need to add some linkers. Okay, so
SDL.
this is
SDL.
yeah, okay, there it is. So we have the window, we have an icon and a title for the window. We have a sprite that we can control with the ASWD keys or the arrow keys. We have this SDL2 true type font bouncing around the screen. And whenever it bounces off the wall, it says SDL. We also have this background drawn on top of the render. So it's got see-through, the background is partially see-through. So when you press the space bar, we can change the background render color to a random color, and it also says C. So this is showing you how to deal with music, how to deal with sound effects, how to deal with collisions, how to draw things, how to create text and move things. Everything kind of you need to know to get going with creating your first games in SDL3 and the C language. So let me just show you where we left off with in the last video. So here we have the window being drawn. We have a title, we have the icon, we have a background color. We can press the space bar and it changes the render color. So in this video, we will be loading up a new module for a true type font. We'll be creating a font. We'll be creating a surface that has something written on it. We'll convert that surface to a texture and then we'll be displaying it. Okay, so that's what we're doing in this video. So let me just show you right away. We are going to be bringing TTF online. So we're going to use TTF init. And we do need the header file included for this. It's not right here. We need this SDL_TTF /SDL_TTF_H. And we need to include that. And we need to bring TTF online. There are no parameters in it, and it returns a true on success and a false on failure. Okay, so it's a little bit different than SDL2, as in SDL2 would be 0 on success or -1 on failure. This one is true on success and false on failure. And the way we bring it offline is the exact same way. So let's do that. If you don't know, we do need to bring this module online before we do anything in the kind of working with true type fonts. So this is the first step. So I'm going to put this in where I'm initializing SDL. Right here, we're initializing SDL with the SDL flags, and it's going to look exactly like this. So I'm just going to copy this. I'm going to yank it I'm just going to put it here. And this one will be called TTF init, and it'll have no flags. And it's going to complain when I save this because I have yet to add in. So we kind of skipped ahead. Let's just fix that real quick because we did not yet add into our H file. We have SDL, we have the SDL main, which is optional, and then we have the image module brought online, or we've included the header file for the image module. Now we need to include the header file for the TTF. So this would be SDL3, TTF, and then SDL TTF.h. And that will give us access to the functions and everything. Now it's no longer complaining about this. So let's change our error message. This says error initializing SDL3, and I'll just add in an underscore TTF. And in SDL3, there is no TTF get error. It is just SDL get error. So that's the same. And this bang is correct because we are checking if this failed. If it failed, then we're printing on the message and collapsing down. So that's all that we need to do to bring it online. And since we've brought this module online, let's also take this module offline with ttf_quit, which will be in game, where we clean up the game itself, game free, right here. This is where we're taking the module offline SDL. Since we brought the TTF one on after SDL, I'm going to remove it before SDL. So TTF quit. So that brings our module online so we can use it. And when where game cleanup is run, it's taking it offline. Okay, there's nothing really to be seen now. We've just brought the module online and offline. So let's just move on to the next set. So this is just giving us access to the good TTF stuff. This is make sure it's all cleaned up. So we do need to create a font now. Before we create any surfaces that use the font, we first need to create a font. So this is TTF open font. It returns a pointer to a font. So this is very much like returning a pointer to a window or a render or a texture. This is returning a pointer to a font. We need the name of the font right here. This is the location of the font. And this is the size of the font. It's in point size, not pixel size. So we're going to need to set this up, and we're going to hold this in our game struct. And I'm going to create some pound defines that are going to hold on to the size of the font and what the font's going to say. First, it's just going to be the size of the font. So let's go back into H. I'm going to make the size of this font quite large because it's going to be the big font that you see bouncing around the screen, or the big text that you see. So I'm going to make it 80. This is just a number I made up, and you can play around with changing this number. So I'm going to say font or text size, and I'm going to put it as 80. I'm going to put this in load media because what I'm doing is I'm building a texture. So I know I'm not loading an image to texture, but I am building a texture. And the first thing I'm going to need is this font, but I'm going to put it in this function, but it does need to exist in game.h. So I do need to put a spot here to hold a TTF pointer to a TTF font. Since I'm only dealing with one font, I'm just going to call it font. And it is a pointer to a font, sorry. Okay, so this is going to give us something to save our font in. Now we can go into load media and we can use this open font. So I'm going to do it just like this up here, since this TTF open font is returning a font. I already have the font placed to where to store it. It's in G font. So it's going to be like that. And it's going to be TTF open font. And now we know we need the location of the font itself and the size. Now the size we've just put in main.h is 80. And it's returning a pointer to TTF font. So where's this font that we're loading? Well, I've included it into the fonts. And this is freesansbold.ttf. So if you want to play around with other fonts, you could just put a different font in this folder and then change the name that you're going to load. So the binary is going to be in the same directory, so it's relative path. So I'm going to say fonts and freesansbold.ttf. So that was the first thing we needed. The next thing that we needed is size, and we saved it as text size. So that's all that we need, and this is going to return, hopefully, a populated pointer. If this fails, it's going to return a null pointer or null and failure. Okay, so the way that we're checking to see if this failed is the exact same way we're checking if this up here failed. So I'm just going to copy that, put it there, and this one we're checking the font. So if the font failed, we can say error loading, I'll say opening font. And again, there is no TTF get error in SDL3. It is just SDL get error. So we're going to use that same error message we've already used before. So this is allocating memory on the heap for this font. So we do need to take care of cleaning it up. So the reverse to this open font is TTF close font. So this is just like destroying a texture, destroying a window, destroying a render that's releasing that memory. So this is the same thing. It takes the pointer to the font, it does what it says, and it's not returning anything. So we're going to go into game, go to game free function. And since it's the last thing that I've created, it's going to be the first thing that I'm removing. So the first thing I'm going to do is check to make sure that this is a valid pointer. So I'm going to see because if it's already null, I don't need to do anything with it. Also, I don't want to be running functions that dereference null. So to be safe, it internally is probably checking this, but I'm just going to be safe and make sure that is a pointer is a non-null pointer before I process it. So font, that just, I mean, if it's null, that this if statement is going to come back as nothing. So now it's TTF close font, and then the font, which is G font. And now we don't want our dangling pointer. We want to make sure that we've set our pointer to null since we freed it. So we want font equals null. And that is taking our font offline. So we've loaded the module, we've opened a font, and we've closed the font and unloaded the module. We need this. This is actually creating the font that is going to be, basically we're going to create a surface that has something written on it. So that's going to be right here. This TTF render text blended. This actually takes our font that we already have. It takes some text that we tell it to, and it creates a surface with that text of the size of the font, written on it. And it's also going to take a color. Okay, so right here we have this TTF render blended. I'm using the blended version, so it's like has nice smooth round edges. It doesn't look pixelated or anything. And it's returning a surface, not a texture, but a surface. So we will convert this to a texture. But we need a pointer to a font, which we already have. We need some text. We need this is the length of the text that we're inputting. And I believe we can just put this as 0. The length of the text in bytes. So it says in bytes. So this already is a little bit confusing to me. Or 0 for null terminated text. So we're going to put 0 here. I'm just going to use the null terminated version for size t length. And then we need this SDL color. So an SDL color is just a struct that has 4 uint8s. So we've seen this in the last video when we were setting the render draw color. We didn't see it as a struct though. We just saw the individual red, green, blue, and alpha. So this is just the exact same thing, just packaged up into a struct called an SDL color. So we have red, green, blue, and alpha, and they're going from 0 to 255. So 0, 0, 0 would be black, and if we put 0 on the alpha, it would be see-through. And 255 all the way down would be white, and on the alpha channel, it would be solid. I'm going to put this color also in the header file, and I'll call it text color. So right here we have text size, text color. And what I want to do is I'm going to set it up as like in squirrely braces, but cast to an SDL color, if that makes sense. So this will be SDL color. And then I'll do and I just want it to be white. So I'm going to make 255, 255, 255, and 255. But you could play around with these colors and change them to whatever you want. And the actual text that I want to write is, I'm going to also define it here, but we could put it in the function, but this just makes it easier. So I'm going to say text, and I'll just call this string. And I'm just going to say SDL, all capital. Again, you can play with this and change it around and see different things. Okay, so we are going to be using that function now, and I'm going to put it in load media, where we are creating the surface, but we didn't put the surface in the game struct, and I'm not going to hold on to the surface in the game struct. I could. I'm just going to allocate it on the heap, but keep the pointer right here in this local scope and remove it right away. That's what I'm going to do. That's my strategy here. But you could also put it into the game struct, just like font and background is. You could do that if you choose. But I'm going to just kind of put it on the stack here. The pointer, not what's allocated. It's allocated on the heap. So it's type SDL surface. And I'm just going to call it surf or surface. It doesn't matter. I'll just call it surf equals. And now we have that TTF render text blended. And this underscore. Now, like I said, if you wanted to do this right here, you would put this in game struct and then you say G arrow surf, right? Okay, so the first thing we need is the font. So we have G font. And then we need the text, which I've put in the main.h header file. That's text string. And then we need the length, which I'm going to put 0 so it's null terminated. And then we need the color, which is text color. Okay. Now, if this fails, this returns null, or if it succeeds, it returns a populated pointer. So we're going to check again this exact same way we did above to see if this is a null pointer. So on this one, it's just surf. It's surf, and I'll say error rendering text to surface. Rendering text to surface. That's fine. That at least kind of lets me know what just happened. And we are going to take this down. The way we free the memory to a surface in SDL3 is SDL destroy surface. So the name has changed, but it does the same thing as what it did in SDL2, SDL free surface. So it's called destroy surface now, which makes it fall in line with everything else. So since this pointer is held in the scope here and it's going to go out of scope and we're going to lose this, you lose access to this heap allocated memory, I'm going to free it. Sorry, I'm going to destroy it. Okay, just like that. We are going to use it before I destroy it, but I just want to, since I've created it, I want to make sure that this exists to destroy it. But what we really want to do is we want to convert this surface to a texture. That's our target, is to get this texture with something written on it. We don't want to deal with the surface. So we can say create texture from surface. So we can take a surface and we can turn it into a texture. And what we need is we need a pointer to the render and a pointer to the surface. And this is going to return a pointer to a texture. So that's what we want, the texture. And we're going to check this texture the same way. If it's a null pointer, it's failed. Otherwise, it's good. This is built into normal SDL. So I do want this texture. So I'm going to hold this texture in the game struct. So I'm going to call it text image. So I'm going to change the name of this to fall in line with the other stuff to text font. And this one will be called text image. We'll need to fix this and load. It's complaining about this right here because we changed the name. It's text font, and the third one is here. So we have this surface that it can go to now. So what I'm going to do is, before we free the surface, I'm going to call that function to convert the surface to a texture. If I free it first, then it's going to be a freed memory, but still have a pointer to it. So that's not a good idea. That would be a dangling pointer. But I just wanted this to exist so I know that I'm cleaning up after myself. So this one is G text image. That's what our texture is going to be. And this is SDL create texture from surface. And we need the render. And we need a surface. which is just called surf. So what's going on here is we've created this surface. We're making sure that the surface is valid. If it is valid, we're creating a texture, and immediately we're freeing the surface. After we've done this, we're going to free the surface. We can also set it to null. Okay. But we don't know if this texture got populated correctly. So we need to check this. Now, I'm freeing the surface before I check it, and I'll explain why in a minute. So let's yank this right here. Or actually, since I'm checking a texture, this is already closer. We're checking text image. We'll say error. Let's change this one. We'll say creating texture. Creating texture from surface. So the reason why these are here is because if I were to put them down here, well, what happens is, think about this. We're allocating memory on the heap. It was successful. If it's not successful, we bail out here and this is a null pointer. It doesn't matter. But we're assuming that this is successful. So we have a good pointer with memory allocated to it. We need to use it here. What if this fails? If this fails, we're here and we're bailing out and we never freed it. So basically, before I check this, I'm already going to free the surface. So if this succeeds or fails, no matter what happened with this function, this is freed. So this may be a good pointer or maybe a null pointer. I free it no matter what first, and then I check to see if it's good or bad. Okay, that's just because this pointer is held in this local scope, and it's going to go out of scope. So I need to deal with this. But if you want, you can do it this other style here, and you can put it in the game struct and hold on to it there. This one is basically getting freed right away, right after I've created it, because I really just need the texture. Okay, so this gives us a texture. And the way that we free the texture is going to be, since this is in game struct, it's going to be in game free. And I need to change the name on this. So the texture I'm freeing is almost exactly like this one. And I'm going to put it on the top here. And it's called text image. And we are destroying text image. And we're setting text image to null. So we can actually go ahead and draw this now, although it's not going to draw the way that you think, because we haven't set up any rectangle yet. It's going to be stretched and it's going to look terrible. It's going to be kind of pixelated and everything else because it was actually drawn at a certain size and then it's going to be stretched to the whole screen. But let's just see it being drawn. So I'm just going to go down here and I'm going to do it exactly like this right here. And I'm going to do it underneath it, so it's being drawn on top. So we've already seen this render, SDL render texture. We have the pointer to the render, and then let's instead put in the text in the image right here. So what it's going to do is it's going to be stretched. The SDL is going to be very pixelated and stretched to reach the whole screen. This one right here. I do need to add in this -L, SDL3, TTF. There we go. So we see that the text is all stretched out, right? And it's pixelated but blurry. This is actually because the SDL3 is trying to blend. You can actually set it to be pixelated. It's not important for this video, but here it is, this scale mode right here. I'm just going to yank this. There we go. Okay, so this is setting the scaling to nearest. There is going to be a way to set this by default, but not right as it stands at this moment. It's by default, it's linear. And this kind of gives you a little bit of smoothing. But if you use games where you want it to be pixelated, even when you scale it, that becomes annoying. You don't want it blurry. So you can actually set it to nearest instead of linear. So we have nearest, linear, and pixel art. Improve scaling for pixel art. Oh, okay, that's interesting. So let's look at this. Sorry, this is just a tangent. Now we see that it's more pixelated. So this image is not actually not pixelated at all. The problem is I've just taken something small and I've stretched it bigger. But just in case your project that you're running with was using like pixel art style and you were scaling it to different sizes and you didn't want it to be blurry, you would need to use this function right here, SDL scale texture, SDL set texture scale mode. And if you don't want it to be blurry and you want it to be, you can either use nearest or what was the other one? Nearest pixel art. Scale mode pixel art is another option. So just throwing that out there real quick. Our font is not going to be pixelated, but I know that when I'm making this Minesweeper, I do need to do this right here. So I'm just going to leave this. It's not going to hurt anything right now. But the problem is we're dealing with, we're taking this text that's supposed to be 80, size 80, and we're stretching it to the whole screen, and we actually don't want to do that at all. So we need a rectangle. That's what's really happening here. I was just showing you about this pixelization. Sorry about that. But what really needs to happen is down here in game, we are saying I want to render this image, and I'm using the entire surface, the entire source, which is the texture. I'm using the whole thing, the bit that says SDL. And then this here is the destination rectangle, which is the entire screen, the entire render. And I don't want it to do that. It's stretching it. So what I need here instead is a rectangle. And in SDL3, this right here, if we back up a little bit, this function, I'm just trying to get it to pop up on my LSP. This function doesn't use an SDL rect, it uses an SDL.f rect. So in SDL2, it used a rect, which was 4 ints. But in SDL3, it uses an f rect, which are 4 floats. So this is different. Okay, so let's look at that real quick. So f rect right here is just a rect of x, y, width, and height, all in floats. So we want to use this. And basically, I want the width and the height. So I'm scaling it correctly on the screen. So I'm fine with x and y being 0, 0, but I want the width and the height to be the correct width and the correct height. So when it displays on the screen, it is in the right spot. So where could I get the width and the height? Well, I could do it several different ways, but the easiest way is to look at the surface. When we have the surface, there are 2 members of this surface that are width and height. So I can just grab them directly from here without running a function that could fail. The only issue with this is these are ints, and I'm saving them as floats, and depending on how strict your compiler is, it may complain. So if you have stricter flags. So I'm going to cast these, but I'm just going to set them directly from here. So I do want this rect, so I'm going to hold on to this rect in the game. And we'll call this text rect. So this is SDL f rect, and it's not a pointer, it's just a normal rect, and we'll call it text rect. Okay, so we have this text rect. So when we go back into load media, and we are, we don't need it. It's not doing anything. It's not harming anything, but we don't need it for anything. So we created this surface, right? And then here we're going to use the surface and get rid of the surface. So right in here, I can populate my width and my height of my rectangle. They're all going to be zeroed out by default because this is heap allocated. In the last video, we switched it to heap allocated, right? Yeah. So it's using calloc. So it's all zeroed out. So it's going to be 0, 0, 0 for the floats, or 0.0, 0.0, 0.0 for the floats. So what we can do is we can set the width and the height here. So I can say G, and it's text rect.w, and it's surf, and then we have w. So we can just get it simply like that. That's because we already had a surface. If we had a texture, we have to run a different function on it. That could fail. It's just slightly more complicated than this, but this is very simple. And this is going to give us a width and a height for a rectangle. And then if we go into game where it draws, we can now use this rectangle. And this is the source. So this is the how much of the original source texture that we want to use. And this is the destination. So right here is where we want this rectangle. And we do need to send in the address to it. So this will be G text rect right there. Now it should be displayed at the correct size, and it will be in the top left-hand corner because an X and Y are both set to 0. And I didn't cast this, so we're going to see if the compiler complains about this. And it didn't complain, and there's our SDL in the top left-hand corner. So if I were to change the, where is it? Sorry, load media. If I were to change X, textrex.x, and put it at, say, 200, it's going to be in a different spot now. Okay. Now, this is fine with what the simple one is, but if I use my make file and I say make release, it doesn't like this at all, okay? Because I'm using strict, when I use release, I use quite strict flags and I turn all my warnings into errors. So it's going to warn me about this, and then it's going to turn that warning into an error. So what I really need to do, because I don't know what system you're on or what, how strict you want your compiler set up, I'm going to cast this int to a float. And then that's fine, and I can run it. Okay, so I'm going to remove this here. I guess I'm just going to leave that commented out. It's not doing anything, just for anybody else that wants to look at it. Okay, so we now are using this destination rectangle, but we are just getting it from the surface. Later on, we will see the other way to get it from a texture, because when I load the player sprite, we'll get it from a texture directly, and we'll use a function call to get it. But this one, we can just do this, since surface already has a member called W and a member called H, as long as we cast it, it's fine. Let's just go over what we've done here. So in H, we had to bring in this SDL3 TTF / SDL TTF.h. That gives us access to it. And we also set a text size that we're going to be setting our font to, and a text color that is just white. And we do need that. If we leave off this bit right here, it won't know what these are. It won't know that it's a SDL rect. And here's our text string. So I've just put those there to make it easy. So in init, we are initializing it. There's no parameter, so it's just TTF init. And we've just created this error message, which is just slightly different than this one. And that's about the same. In game, we are taking it offline with SDL quit in the free right here. Now when we're in the load media, because we're targeting trying to get this texture with something written on it, we need to do a couple different steps. One, we need to open a font. So we got the path to the font, we have the size of the font, and it's going to return either a good pointer or a null pointer. So we're checking that. And then we can write it to a surface. We can't write it to a texture directly, so we're writing it to a surface. So we have this TTF render text blended. And this pointer, we're just holding it in the local scope. But this is taking the font, the string, how long it is, or if it's null terminated. Right here, the 0 means it's null terminated. And the color right here. we're taking those and we're hopefully populating this pointer. This is the check on it. So if we are, we can get the width and the height directly out of it to a rectangle that we've put in game. So in game, we have this SDL.f rect. That's our rectangle. We also are holding on to a font pointer, a TDF font, and a new texture. So in here, we're populating the width and the height of our font with the width and the height of the surface, and we are casting them to float, so more strict compilers won't complain about this. Now we are taking the surface that we have and we're converting it to a texture. So we need the render, we need the surface there. Before we even check this, we're going to free that surface. No matter what, we want it freed. We're setting it to null. And then we're checking that texture to see if it is good or not. In game, we need to clean these up. So we are destroying a texture the normal way that we destroy a texture and setting it to null. We are closing the font and setting the font to null. And the way that we're drawing it is down here in draw. We're drawing it exactly the way we did the background, except this time we are using a destination rectangle. And this destination rectangle simply has the width and the height populated, but we can change the X and the Y to move it around, which is what we'll do in the next video. We'll be moving around the text to bounce off the screen. Okay, so I think that is about everything. I hope that was entertaining or educational, and I will see you in the next one. Have a good day. Bye.